In this video, I'm going to be talking about phagosome fusion, and it does have to do or is related to phagocytosis in macrophages and neutrophils. So phagosome fusion, phagosome lysosome fusion is a key step in the innate immune response where an engulfed particle inside a phagosome is degraded and destroyed inside the lysosomes. So if you've seen my other videos related to lysosomes, you already know what they do. So as for those that haven't seen those, I advise you watch my lysosome videos. So after a cell, like a macrophage or neutrophil, engulfs a pathogen or cancer cell, it forms a membrane-bound vesicle called a phagosome. This phagosome then matures and fuses with the lysosomes to form a phagolysosome, which is highly microbicidal or microbicidal. So the main goals of phagosome fusion is pathogen killing, such as bacteria, fungi, parasites, degradation of ingested material by the macrophages, even antigen processing for an adaptive immunity, so possibly has to do with antigen-presenting cells, and then resolution of cellular debris. So phagosome fusion is a part of CD27 on the T cell, and then CD70 on the antigen-presenting cell. That is what is needed so that the APC can train the naive T cell so that the T cells know what to do when they are battling cancer cells, since they cannot be naive and untrained or else they will be ineffective. So inside the phagolysosome, these proteins that are degraded are turned into peptides, and then the peptides are loaded onto MHC molecules and then displayed on the surface of APCs, such as macrophages and dendritic cells and B cells. So the phagosome fusion enables the activation of adaptive immunity via CD27 and CD70. So there is a cytokine that regulates the phagosome fusion, and one of them is tumor necrosis factor alpha, or TNF-alpha for short, that promotes the phagolysosome formation. That way, antigen-presenting cells, they can train T cells so that the T cells are not naive. Another one that supports the phagosome lysosome fusion is also one I've talked about in other videos, and that is IFN-γ, a very potent cytokine. IFN-γ can be boosted by arginine, or let's say a watermelon has citrulline and then boosts arginine. Arginine boosts IFN-γ. Also, calcium signaling is also involved in the phagosome lysosome fusion, because calcium regulates a vesicle fusion dynamics, because there's like machinery and vesicles and ligands that allows the fusion. So you can find calcium in cheese. Might be better not to take calcium supplements, because then calcium could get too high and then collect in the arteries and leading to plaque and atherosclerosis. So once there is the fusion of the phagolysosome, the functions are acidification, lowers pH to 4.5, activates digestive enzymes, but also enzymatic degradation. Nucleases break down pathogens, maybe even cancer cells. And then there's also reactive killing with ROS and RNS, also generated by nitric oxide, which arginine upregulates. Another cool thing about this fusion is that the lysosomes, the enzymes in the lysosomes, they break down the pathogen components and dead cell debris and dust and apoptotic bodies. That's after macrophages or neutrophils, they engulf or do phagocytosis to take up all of those things that I just mentioned. And then the lysosome enzymes break them down into amino acids, fatty acids, sugars, and then these products can be used for antigen presentation. So APCs, they use the amino acids, fatty acids, and sugars to help train naive T cells. Okay, this is where magnesium is important for repair enzymes of the lysosomes, so that the lysosomes are not leaking the cathepsins, because once the lysosome fuses with the phagosome, the lysosome delivers the cathepsins inside the phagolysosome, so that as a protease, so that the cathepsins can degrade either the debris or dead cancer cells or the amino acids and fatty acids and sugars for the APCs to use to train naive T cells. But the cathepsins can't leak out of the lysosome because of a magnesium deficiency. Now, on to foods that modulate TNF alpha. But this is where too much of a good thing could actually be bad, because these following fruits, which are foods, they actually reduce TNF alpha. So if TNF alpha goes down too much, then the phagosome cannot mature, and then cannot fuse to the lysosome after macrophages and neutrophils engulf debris or cancer cells, and then the antigen presenting cells, they cannot receive fatty acids, glucose, amino acids for the T cells, or to train naive T cells. So some of these fruits are oranges, rich in vitamin C, can reduce TNF alpha production, therefore supports immune balance. So pretty much most of these fruits reduce TNF alpha. So kiwi, mangoes, coconuts, which is high in fat, those reduce TNF alpha. Apples, pears, those reduce TNF alpha mildly, but probably the strongest TNF alpha modulators are grapes. Strongly suppresses TNF alpha. Grapes have resveratrol. Also, blueberries, a very high anthocyanins and potent downregulator or suppressor of TNF alpha. So that possibly means that having too many blueberries or too many grapes could suppress the fusion of phagosome to the lysosome, therefore weakened T cells, because they are not being trained by the APCs. And then other foods that can reduce TNF alpha, but not so much, is strawberries, cherries, watermelon, bananas through gut microbiome, peaches lowers TNF alpha, tomatoes, avocados, papaya. Pretty much, these all reduce TNF alpha. Okay, so those fruits are good to maintain lower TNF alpha, because if TNF alpha is chronically high, it is linked to conditions like rheumatoid arthritis, inflammatory bowel disease, even type 2 diabetes. So it's good to keep TNF alpha lower and not too high. But of course, excessive foods, or the ones that I mentioned, especially blueberries and grapes, those potently reduce TNF alpha. That goes to show that way too much of a good thing can be a bad thing. So to avoid having way too many fruits, they are good, just not too many. If they are excessive, then that's going to weaken the immune system, because the phagosome is not fusing to the lysosome, and then the cancer cells, the debris cannot be broken down or degraded after macrophages engulf or clean them up. And then the APCs are not receiving the byproducts of the fusion, which is amino acids and sugar and fatty acids, to train naive T cells. Therefore, naive T cells are going untrained and cannot battle against cancer cells. So that's how lowering TNF alpha too much can weaken the immune system. So that's it for the video. If you're interested in more future videos, then make sure to like, comment, and share this video with any people who are concerned with their health, especially when it comes to cancer. Keep it locked in here on my channel, and I'll see you in the next video.